In this video, I'm going to talk about what a solstice is and what an equinox is and why they happen. When you're done watching this video, you should be able to tell me when and why the annual solstices and equinoxes occur. So just a quick review. As you learned in the video on the seasons, the Earth has a tilt of 23.5 degrees off perpendicular, and this tilt causes parts of the Earth to receive more direct sunlight during certain times of the year, and the tilt and the Earth's orbit work together to cause the seasons. And so more direct sunlight is what we see in the summer. It heats up the Earth more and gives us warmer temperatures, and less direct light or indirect light comes in the winter. It comes in as a lower angle and it doesn't heat up as well. If we think about how the sun moves through the sky, this also changes over the course of the year. If this is the east and the west, as we track the sun's path using a time-lapse camera, in the wintertime we'll see that it rises over here on the horizon and doesn't really get up very high in the sky before it sets over here. And of course that shorter path also gives us shorter daylight hours in the winter. And then in the summer, we'll rise over here in the east and take a much higher and longer path across the sky until it's time to set in the west, which again contributes to those higher temperatures and longer daylight hours. Now, this sun's place in our sky is determined by where the most direct sunlight is hitting the Earth, thinking about the Earth as a whole. If you were at that spot where you're getting the most direct, coming straight down perpendicular onto you, the sun would be directly overhead at noon. So if you went out at noon, the sun would be right over your head. Of course, in this diagram, then it would be this central ray. So if somebody was sitting in this part of Africa, at noontime, the sun would be directly overhead because the sun's rays are going to be hitting the Earth in a perpendicular fashion. So the summer solstice is the word we use to describe the day that the sun reaches its highest point in the sky. And then, of course, the opposite, the winter solstice, occurs on the day that the sun reaches its lowest point in the sky, on that path that we see across the sky. These solstices occur around June 21st and December 21st every year. It's around because our year, remember, is 365 and a quarter days. So leap year will change the date, but it's somewhere around this. Maybe it's the day before, maybe it's the day after, but somewhere around those dates. So going back to this very first picture, the day that this particular path occurs on would be our winter solstice. That's the lowest path in the sky. The day that this path of the sun occurs would be our summer solstice. And on the days in between, moving from winter to summer, each day the sun would be just a little bit higher in the sky, working its way up until you get to the summer months. And then after our summer solstice, it would come and work its way back down day by day, just a little bit lower, tiny, tiny amount, until we get to our winter solstice day. In order to experience the sun being directly overhead at noon at the summer solstice, you do need to move a little bit closer to the equator. In fact, it is all along the Tropic of Cancer that the sun reaches that most direct line on the Earth at the summer solstice when you're in the northern hemisphere, and it's along the Tropic of Capricorn if you're at the summer solstice in the southern hemisphere. So if you ever wondered what those two other lines were on the globe, of course we've got the equator coming down around here, and then there are these usually like dotted lines. Here's the Tropic of Cancer and the Tropic of Capricorn. They're really marking the sun's path. So that this would be the point somewhere along this Tropic of Cancer. You'd have to be in that country on noon on the day of the summer solstice, and then the sun would be directly overhead. It's never going to be directly overhead where we live further up north in the northern hemisphere. So this picture is showing that. Here's the sun ray coming in perpendicular to the Earth, and this line right here is our Tropic of Cancer, showing the summer solstice, and the Earth's axis tilt is going to the left in this particular diagram. And on this diagram showing the summer solstice for the southern hemisphere, Earth's axis in this case is tilted to the right. Here's our sun rays coming in perpendicular, and of course here's our Tropic of Capricorn. So that's just what those lines are for on the globe, all talking about the sun's path. So the length of daytime hours, daylight hours, are the longest on the summer solstice, whether you're in the northern or southern hemisphere, and they are the shortest in the winter, again, no matter what hemisphere you're in. But the exact number of hours depends on location. Here are some example cities. If you happen to be on June 21st, the summer or winter solstice, depending upon whether you're in the northern hemisphere or the southern hemisphere. So summer solstice in the northern hemisphere, the Arctic Circle will get 24 hours of daylight. And you can see the North Pole here is in sun. And if you can kind of picture the Earth turning around, you can see that this part is always going to stay in the sun. And there are several days where the sun is always shining in the sky in the North Pole. Quite a few days, actually, months and months. Then at the Tropic of Cancer, there are 13.5 hours of daylight. And of course, in between, it's going to slowly move from 24 to 13 as you're moving south down the Earth. At the equator, you have 12 hours of daylight, and then going into the southern hemisphere, which is, of course, their winter solstice, daylight hours get shorter at 10.5 hours at the Tropic of Capricorn and any of the places along this line. And then down in the Antarctic Circle, you have 0 hours of daylight. It is all dark all the time. So then that's your solstice. The equinox, which kind of looks a little bit like equal in how it starts, at the equinox, your daytime and nighttime hours are equal along the equator and almost equal all over the rest of the Earth. The sun is directly overhead at the equator, just like it's directly overhead on the Tropic of Cancer and Capricorn on your solstices, and your equinox occur in between, so somewhere around March 20th in the spring for the northern hemisphere and September 22nd again in the fall for the northern hemisphere. So this diagram, we've lost our tilt, so it's just showing the Earth's axis straight up and down, but again, trying to show that the perpendicular rays are going to come here at the equator in the center of the Earth, but really the whole side of the Earth here, from the North Pole to the South Pole, everything will be able to have daylight because the sun is kind of aimed directly at the equator. The spring equinox has a fancier name. It's also called the vernal equinox, and the fall equinox is called the autumnal, like autumn, equinox. So just like the seasons, a solstice or an equinox is caused by the Earth's position, its tilt, and its revolution or orbit around the sun. Those two things work together to cause these phenomena that happen every single year. So let's use what you've learned to label the solstice and equinox points on this diagram. Starting again on the left, remember this position was our summer season in the northern hemisphere and the winter in the southern hemisphere. And so this position is going to be our summer solstice for the northern hemisphere and our winter solstice for the southern hemisphere. And then all the way on the opposite side of the diagram, going all the way over here on the right, our northern hemisphere is now going to be experiencing the winter solstice. And the southern hemisphere will be experiencing the summer solstice. These occur on the same day, but it depends whether it's winter or summer, depending upon which hemisphere you live in. And then, of course, going from summer to winter, the one in between is going to be our fall equinox, or the autumnal equinox for the northern hemisphere, and then the spring equinox or the vernal equinox for the southern hemisphere. And then again, our last diagram going from winter into summer for the northern hemisphere, this would be our spring equinox. And in the southern hemisphere, they're going to be experiencing the fall equinox. So check for understanding. Can you explain when and why we have a summer and winter solstice and a spring and fall equinox? Again, this is an important science concept that you need to know.